All right, welcome back. Now I'm going to go over a couple of things that you may already be aware of from previous discussions, previous lectures. But I want to go over them again because we're going to be using this going forward for this section here. So we're going to talk about motion along the line. So again, this is going to be a little bit of review. So the first definition we're going to talk about is this. So four things here, 4 bullet points that I want to cover. First one says, let S of t be a function giving the position of an object at time t. Well, maybe that should be there, 3 bullet points. So the velocity of an object at time t is given by this formula. V of t is the derivative, the first derivative of f of t. Now, velocity, so one thing you need to understand is velocity involves a direction. Okay, so in many things, many applications, there's a difference between velocity and speed. Velocity includes a directional vector. So it's a vector. Technically, when you study physics, if you haven't studied physics already, but velocity involves a vector component. It's a vector, so it includes 2 things. There's the magnitude of the vector and the direction of the vector. So when you're talking about velocity, velocity is a vector. So it's going to have both the magnitude, which represents speed, but then there's the directional component as far as what direction it's pointing or moving, right? If we're talking about a particle moving in a direction, we're going to be talking about velocity. But if we're talking about speed, then we're only interested in how fast the particle is moving. We don't care about the direction. So for example, if I say that a rocket is moving at negative 320 meters per second, well, the negative would give me the direction. So if it's moving in a negative direction, we might say that it's moving towards the earth, right? Or if a rock is falling at a certain velocity and that velocity is negative, we would say the rock is going towards the earth versus away from the earth, okay? So that would mean, but if I say the speed of the rock is 320 meters per second, or the speed of the bullet is 500 feet per second, then what I'm talking about is just the speed with no directional component. That's the difference, okay? So the velocity of an object is given by the derivative of the position function. And this would include a directional component, so it could be negative or positive, okay? Now the speed of an object at a given time t is given by the absolute value of the velocity function of instantaneous velocity, because again, we don't care what the direction is, so it's always going to be positive. So that's why we always use the absolute value, because again, it's like displacement, right? We don't care what direction the particle, or how far the particle is from its origin. We don't care about the location. Well, the location. All we care about is the distance from the original location. That's what we call displacement. Okay. Similarly, with velocity and speed, the same thing. So we always take the absolute value of the velocity function to give us the speed, whereas we always take the absolute value of distance, right? Because all we care about is how far it is from the original starting point. And then acceleration of the object is given by the fact that a of t, the acceleration function, is the derivative of the velocity function, or the second derivative of the position function. Okay, so you've seen that before. I've shown you that before. Okay, that's it. So let's move on and we're going to look at some examples.